Today we are going to discuss the few concepts of databases that are super key, candidate key, and finally primary key. So what is a super key? A super key, or simply a key, is an attribute of a relation that can determine all other attributes. So this is the basic definition of super key, and when we say that can determine all other attributes, it means that specific attributes attribute clause should contain all other attributes of that table. So in other words, the attribute closure of the super key would contain all the attributes of the table. So if all the values in a column are unique, that attribute is surely a super key. Because if all the values in a column are unique, then definitely all other columns will be functionally dependent on this column by the definition of functional dependency, and this column would be a super key. But sometimes, even if all the values are not unique, still it can be a super key as long as the definition of functional dependency is fulfilled. That is, for the given value of the super key, there should be only one value of any other column. So let's see if which column of this table is a super key. So here this relation R contains 4 columns: ID, name, email, and password. And here you can see that this is the set of functional dependencies that ID can determine name, ID can determine email, password, and so ID can determine all 3 columns, and name can determine email. So if name is A, then email is X, and if name is B, email is Y, and again if name is A, then email is X. So here again for A we have same value of email, so you can say that, and for same value of B we have same value of Y, so you can say email has functional dependency on name. So these are the functional dependencies for this relation, and now we see the attribute closure of ID. Definitely the attribute closure of ID would be ID can determine itself using the reflexive property, and then ID can determine name as from this table, and ID can determine email, yes, and ID can determine password, yes. So ID can determine all the columns of this table, so you can say ID is the super key. But now we see the attribute closure of name. And name can determine itself, so name is here, and name can determine email from this functional dependency set. So this is the attribute closure of name. So attribute closure of name doesn't contain all the columns of this table, so name is not a super key. Next we see email. The attribute closure of email is just email, and attribute closure of password is just password. So here just ID is the super key, and then next here are the super keys. So if you combine all the columns ID, name, email, and password, these combined columns together become super key, because the attribute closure of these 4 columns would be all the columns of the table. Next, if you combine ID with name and email, again it will be a super key, because ID can determine all other columns. So combining these columns will will not have any impact. So still it would be its closure will be all the columns of that table. So it's a super key. So similarly, ID and name is a super key, and ID is a super key. So these are the super keys, and in short you can say all the columns combined together for a given table definitely become a super key. And if one of the attribute is super key, then you can combine any other column with that, and it would be a super key. Like ID is a super key, so combining any other column will still make it super key. So how many super keys may be there in a table? If a table contains 5 attributes and each attribute is unique, here just ID is unique. But let's say if each attribute is unique, then you can find all the possible combination of that table as super key. So all the possible combinations are using this combination formula of statistics 31. And so this is super key. So super key is simply any column or a combination of columns that can uniquely identify each row of the table. And next we discuss candidate key. So what is a candidate key? Candidate key is actually that super key which cannot be simplified further. So the simplified form of the super key is called candidate key. So in other words, subpart or proper subset of the candidate key must not be a super key. So if you decompose the super key and the subpart of that super key is still a super key, then you can say it's not candidate key. Like in above example, if you decompose this composite key, here you can say ID itself is also super key. So here is a super key but not candidate key. As a part of this super key, ID is itself super key. So it's not, it is a super key but it's not the candidate key. However, ID is a candidate key as it cannot be simplified any further. So here we see some more examples for this. Let's say this is a relation with the column W, X, Y, Z and A with functional dependencies. These are the functional dependencies. And super key, now here simply you can make a super key by combining all the columns of the table. So here you can say W, X, Y, Z together become a super key. Next we simplify it to get candidate key using functional dependencies. So here from this combination and also looking at the functional dependency set, you can simplify this super key. So here you can say that if you have W, then you can determine X. So we can remove X from here and simply here say if you can do it in any order. So it says if you have Y, then you can determine Z. So we can so we omit Z here, so we remove the Z from this key, so it is like this. And next if you have X, then you can determine Y. So we remove Y from here, so we get this WXA. And next from this functional dependencies, you can see that if you have W, you can determine X, so we remove X as well. So finally this is WA. This is the simplified version of super key, and the attribute closure of this super key would still be all the columns of that table or all the attributes of that table, and we cannot simplify it further, so it is the candidate key. So now after simplifying this super key, next we have to see if the proper subset of WA is not a super key. Now the proper subset of WA would be W or A. So if you take the attribute closure of W, it is W can determine W, W can determine X, X here, X can determine Y, so we include Y, and Y can determine this, so we include Z. So attribute closure of W is W, X, Y and Z, but it doesn't contain all the attributes of the table because it doesn't contain A attribute, so it is not a super key. Similarly, the attribute closure of A is simply A, and still it's not a super key. So you can say that a subset of WA is not a super key, so WA is a candidate key. So that was the concept of candidate key. And next, finally, the primary key. Primary key, you can make there is only single candidate key. Any candidate key can be considered as a primary key with following condition. There can be only one primary key in a table, and the primary key column cannot contain null values. So if there are more than one candidate keys in a table, you can set one of them as primary key, and there will be only one of them that would be set as primary key. there would be no more than one primary key in a table. And next, you should make sure that that column does not contain any null value. So that's it.